All right, good morning and welcome to our webinar today, Best Practices for Mobile CI. The idea for this webinar came from discussions we had here about how continuous integration is being used today. A lot of modern organizations are widely adopting CI for web environments. However, mobile developers, it's been a slower road, in a large part because mobile brings with it a whole bunch of unique challenges that just make implementation much more difficult. Today we have a couple of speakers who are going to talk to us about best practices in mobile CI. First speaker is Kevin Rolling, who's an entrepreneur with a strong engineering and product background. His work includes being CEO of CI Simple, the first platform to office mobile CI as a service, which he sold to Electric Cloud in 2014. Kevin is currently co-founder and VP of product at Emberlight, an IoT product focused on the home automation market. I hope I did that right, Kevin.
That was perfect.
We also have with us Christian Meyer. He's been a system admin for about 20 years in the IT area and is now a senior system engineer here at Sauce Labs. First, what I'd like to do is start with a poll to get an idea of people's experience in mobile testing. So if we can look at that very quickly, there's 3 simple questions we'd like you to answer. And we'll spend about a minute here looking at this, and then I'll turn it over to Kevin to start slides. We close the poll. We can take a quick look at the results, and then Kevin, it's up to you.
Okay. All right. Cool. Great. Thanks for that introduction, Ken. So as Ken said, the founder and CEO of a company called CI Simple. The spot last year is now rebranded as Ship.io, which is a continuous integration platform focused specifically on mobile, so iOS and Android. Also currently co-founder and VP of product of Emberlight, an IoT smart lighting company. So I'll go ahead and get started. So I'll start at a really high level and just talk about, what continuous integration for mobile, and then go a little bit deeper from there. So at a really high level, continuous integration for mobile isn't much different than continuous integration in general. The same sort of processes that you would use for, say, web applications. At a high level, really what you want is some sort of build process to validate that the code is compiling correctly. Ideally, you have some automated tests, functional or unit tests, that get run as well, just to validate functionality within your code. And then you have some sort of deployment process to deploy this new built and tested code out to actual human beings that can interact with it, most likely testers. So at a high level, mobile or CI for mobile doesn't look much different than CI for anything else, but as you get a little bit deeper, things change quite a bit. So generally, you have some sort of developer who's committing code, and there's a CI server that will pick up the code changes and then recompile them. And then tests are run typically on either a simulator or emulator or a device, and then this gets deployed. So continuous integration, why would you actually need to do this? So in general, continuous integration helps reduce the need for human-based testing. If you're able to automate your tests, or functional, you can kind of offload some of the work that you have human beings doing. Obviously, human beings are expensive, and there's probably other things that you would rather the people on your team be doing than testing your mobile app. Human-based testing is still a really important part of the process, in my opinion, but the more you can offload off of people, the better. Also, continuous integration is going to give you much faster feedback. You can immediately commit code and get feedback that the build is broken or that some tests have failed. That's going to help you fix those changes much faster. And then ideally, you want to automate as much of your release process as possible. So the things you have automated, that's fewer things that people can break. So I'll just touch real briefly on why I use continuous integration on the projects that I work on. So we're using a CI process at Emberlight. Also, I've done quite a bit of consulting projects over the last year or so as well. And I'd say probably 90% of the projects that I've worked on, I implemented CI to some degree. CI is not a binary thing, but I've implemented it to some degree on pretty much all of the projects. And so some of the things that I found to be most useful number one, having like a no-touch configuration process. So I'll just tell a real quick story behind what that means. So a past startup that I worked at a few years ago, we had an iOS application, we had an Android application, we had a BlackBerry app as well. We had builds that were going to the app stores, but we also had builds that went to some of our enterprise customers. And so the configuration for each release was really complex. You know, we had a config file, if you will, for each of our enterprise customers. We had a config file that would go to the App Store. And, you know, those are the things you don't want to mess up, right? Like, you don't want to put a build for an enterprise customer in the App Store. That's really bad news. And so we noticed that this process was getting incredibly complex, and you know, this was a concern for us. So we ended up implementing CI, not for testing and not for, you know, build validation, but primarily just to do very low-touch configuration. Like, we set up a build for each of our enterprise customers. We set up a build for the App Store, and we knew at the end of those builds that this build was configured for this client, this build was configured for the App Store, and there was no opportunity for the developer to misconfigure it on their machine. And so this is, you know, even for less complex projects where you have a staging environment and a production environment, I found this to be incredibly helpful. Just peace of mind, me knowing that this build that I've got here, I know that this is configured correctly. So touch configuration is something that I feel really strongly about, and I feel like that's one of the primary values that I've gotten from CI. Also, automated OTA distribution. So for those of you who don't know what OTA means, that's over the air. So distribution for mobile is obviously different than the way you do distribution for a web application. You can't just do git push, you know, Heroku. You have to upload your build to something like Hockey App, or Tesla while it was still around, you know, these various OTA services. And so integrating OTA into your build cycle, I think, can help save a ton of time. I've talked to a lot of consulting firms that they've spent a lot of time just to have OTA distribution for their various clients, and so they take a lot of time, like just going to the developer and saying, we need to do another build for the client. If you can have this as a completely automated process, every time code gets committed, you have a new build available that you can send them, and you can just log in and click a button. That's incredibly useful. It can be very time-consuming uploading builds to Hockey App and those sorts of things. Also, finally, and this is, I think, what most people hear about, is, you know, automated builds and tests. Obviously, if your code doesn't compile, you want to know about that as soon as possible. If tests are broken, you want feedback on that very quickly as well. So I talked about my implementation of CI and the degree to which I implemented it. It's not a one-size-fits-all process. You know, for different types of companies at different stages, I think there are different business drivers that drive that end up resulting in specific engineering challenges. And I think the degree to which you implement CI depends on what those business drivers are. So, you know, for example, knowing that your code is compiling and that your tests are passing might be really important to a consulting firm. But if you're a really early stage startup and you need to get builds out to investors and potential partners on a really regular basis, you know, your main value might be just having automated OTA, sort of thing. So I think, you know, the value you get from CI and the degree to which you implement it can depend a lot on the type of organization. One size fits all. So mobile is definitely harder. If you've worked on web projects, those sorts of things, and had a CI process in place, and then moved to mobile, I think one of the things that you'll find is that setting up CI for mobile it's just objectively harder. You know, one of the challenges dealing with mobile is that you're probably building an iOS app. I would venture to say that most of the people on this line, if you're developing mobile applications, you're building something on iOS. If that is the case, then you need some sort of Mac machine in order to compile your iOS application and run tests on it. That's just the way the ecosystem works. That means, unfortunately, you can't just go and spin up an EC2 server to host your builds. So you probably have to go out and get a Mac Mini and then configure it. Also, setting up Xcode and various Android SDKs on your build machine. It's just more complex than setting up something for like Ruby on Rails or Node.js. Also, there's this process for compilation and code signing. Obviously there are some web platforms that are compiled as well. Obviously there are a lot that aren't. Ruby Rails and Node.js and Python, these are basically scripted languages. There's no compilation process. So with mobile, both iOS and Android, there is a compilation process that you have to go through as well. And then followed by compilation is code signing, which means that you have to configure your build machine to be able to work with your code signing certificates. So iOS, that means your code signing certificate and provisioning profiles. Android, that means your key store file. And so that adds another level of complexity to the build process. And also there's the testing part. And so doing tests, you have to either interact with simulators and emulators or physical devices. Not only is that challenging to set up, but also challenging to understand what is the right time to use a virtualized solution versus a real physical device. So that's another challenge of mobile science. And then finally, there's the process of deployment. So as I said earlier, you can't just push your code like you can for most web platforms. You have to upload this to some sort of OTA service. So now I want to talk a little bit about simulators and emulators versus devices. So first I'll just talk a little bit about, when I say simulator and emulator, they're not exactly the same thing. There's a very nuanced difference between the two. And then I'll talk a little bit about real devices. So starting with simulators, simulators are what's used in iOS. Simulators are included with Xcode. So when you have a simulator running on your machine, on your Mac machine with Xcode, it's not actually executing the same CPU instruction set that your physical device is. So your phone is running on an ARM instruction set. When it's running on a simulator on your Mac, it's actually running on the instruction set of your Mac. So what that means is that a build you've compiled to run a simulator will not run on a physical device, and vice versa, because they're compiled for different CPU architectures. In practice, this doesn't mean a whole lot, but it's just important to understand that builds for simulators won't run on devices, vice versa, and also that the reason is because the instruction sets are different. Also, because they're compiled the instruction set of your Mac, they're really fast compared to emulators. So when you're interacting with an iOS simulator, it's pretty quick. But one of the downsides of simulators is that you don't have access to certain hardware functionality on the simulator. So, like for example, at Ember Lights, we do a lot of interaction over Bluetooth Low Energy. So we have these physical IoT devices that we interact with over BLE for configuration and interacting with the lights. You can turn them on and off. That's a really hard thing to simulate. You can't really do that on a simulator. The only way to really actually test that and to get access to a BLE radio is to use a physical device. And there's a handful of other device-specific functionality that you either have to fake or just completely mock out, depending upon what your needs are for your application. So that's one of the downsides of a simulator is the lack of hardware functionality. Now, emulators are just a little bit different. Android emulators that's what's with the Android SDK. They actually emulate the instruction sets of the CPU that you're attempting to emulate. So that means that for most devices, it's actually executing an ARM instruction set or whatever that native instruction set happens to be. The downside to that is that it's much slower compared to a simulator. So if you're an iOS simulator up right next to an Android emulator, the emulator is going to be much slower. But the upside is that you know that you're actually running the same instruction set that you're going to be running on the real device. Emulators also do not have access to certain hardware functions as well. So your GPS, Bluetooth radio, accelerators, those sorts of things, you have to find a way to fake that. And so real devices, there's obviously advantages to running on real devices. One of the big advantages is it's really the only way to reproduce the actual performance that your users are going to experience. Just something runs really well on your simulator or your emulator doesn't mean it's going to run well on the physical device. So this is really the only way to test that. Also, it's the only way to catch manufacturer and OEM bugs. This is something I don't hear people talk too much about, but especially on the Android side, there was a project that I worked on a couple of years ago, and we were doing testing with the Note. I think it had just come out. It's like the really big Android device. This was a few years ago when it first came out, and there was a bug that had to do with the way that the unique ID for that device was stored, and it was only on this particular device. Like we didn't see any other devices exhibiting this particular bug, and the only way that we caught that bug was by testing on that specific device. And I would say, especially on the Android side, there are OEM bugs and bugs by the manufacturers. And really the only way to catch those is to run on physical devices. So that's, I think, an important thing to note. Obviously, the downside to running on physical devices is that if you have a device farm, it's really expensive to configure and maintain that. You know, it's the sort of thing you probably will have to dedicate people to, or you find some sort of service, of which there are services online that host device farms for you that you can use. One of the other advantages to real devices is obviously you have full access to all the hardware functionality. So that brings up the next question. When is the right time to use devices? When is the right time to use simulators and emulators? So this, I think, is, again, just like CI in general, this is really dependent upon the organization. But I'll give my opinion. And I think simulators and emulators are great during development. So the advantage of simulators and emulators is that they run really fast and they're super cheap. Right? They're only as expensive as whatever you're paying for your hosting infrastructure. Super fast, super cheap. So whenever you commit code, there's really no reason not to have your tests run on a simulator and an emulator. However, physical devices are a really important part of the process as well. And in my opinion, in the very least, you should use physical devices before you ever release. Potentially even more often. I think this depends upon the size of your organization, what it looks like, that sort of thing. But you could have simulators and emulators running on every single commit, giving really fast feedback, and then you could have physical devices running on either like a daily or weekly, or perhaps just as like a pre-release process. That frequency, I think, really depends upon your organization, whether you have the team size to support your own device farm, the budget to pay for somebody else's device farm. There's a lot of variables that are organization specific there, but I do think it is important to run your tests on physical devices at the very least before every release. So I was touching a little bit on unit testing, and I'll just dive a little bit deeper into unit tests and the different types of tests out there. But before I do, I just wanted to pull up a really interesting survey that I came across recently. It said that 77% of developers said app quality is either very important or mission critical. It also said that 80% of mobile developers are testing their app manually. I actually think that number is probably closer to 100%. I think every mobile developer I've ever come across is doing some form of manual testing. But only about 13% of mobile developers are using automated tests. And I think that's probably a pretty accurate number from what I've seen. So there is a really strong need to have automated testing in place. But there is definitely a lower adoption rate when it comes to automated testing in mobile versus a lot of other platforms. So I like to break unit testing down into two different types. There's unit testing and functional testing. Unit testing basically tests small pieces of code, possibly a single function or a single class. There's some level of testing that's just at a code level, and then there's functional testing, which reproduces user interaction with your application. So button clicks, UI interaction. I think one of the questions that we had prior to this webinar, someone was asking, most of the tools are helping to test mobile applications. What's the best way to test an SDK? So unit testing is really great for testing an SDK, because an SDK doesn't really have a UI in front of it for button clicks and UI interaction, at least not most of the time. So unit tests are great for testing SDKs. They're good for testing parts of your application as well. But I think that they really shine when it comes to SDKs. So some of the benefits of unit and functional testing, obviously, instant gratification. You get immediate feedback if your functionality is broken. Repeatable, you can automatically test every single commit. Challenges associated with unit and functional testing. Unit tests are not users. You cannot get the same level of coverage in your mobile application that you will with human beings. Like I said at the beginning of the talk, offloading as much as possible off of human beings is a really, really good thing, but human beings are still a really important part of the process. In addition to testing on physical devices, I strongly recommend always testing on physical devices with human beings before every single release as well. It is a lot of work to write and maintain unit and functional tests. That might be why only 13% of mobile developers are actually doing them. It is expensive, and whenever you change functionality in your app, you have to change the tests that are written around that functionality as well. And there are a lot of people that just don't know which framework to use. There are a lot of frameworks out there. I think a lot of people just kind of get stuck at, I want to write tests, but I don't even know where to start. So I want to address that question, because it's one of the more popular ones that I hear is, which testing framework should I use? And usually the first question I ask is, what language or frameworks do your developers know? If you have people coming from a Selenium background, Appium is an awesome choice. If you have somebody coming from let's say a JavaScript background and doing an iOS application, UI automation is a really good choice. If your iOS developers are just really good iOS developers, there are excellent tools baked into Xcode, like XCTest, for example, that are really good unit test frameworks. So I think that the most important factor in which testing framework you choose is, what do your developers already know? So another important factor is open source and community support. If it's an open source framework with really strong supports, then that's really, really good. And Appium is one of those as well. Excellent supports, open source. Last thing you want to do is run into a bug and have no way to fix it. Also, third-party framework requirements are really important as well. So just to give you an example, KIF is a functional testing framework that I really like. One of the downsides to using KIF is that it brings in some dependencies and uses some private APIs that if you were to release that into the App Store or try to, Apple would reject your app. So it's important that when you're configuring your KIF project that you don't accidentally end up releasing that part of the code into your app. So it just adds some level of complexity to your configuration. It's not necessarily a bad thing, it's just something to be aware of. So third-party framework requirements, I think, are also a really important thing to look at when you're deciding which framework you're going to bring in. So finally, I want to touch on some of the CI tools that are available for mobile. I think Jenkins is one that everybody has heard of. It's not just used for mobile, obviously. It's used for CI for just about everything in the world. One of the things about it, it's open source and has tons of plugins. The downside to Jenkins is that it is self-hosted. It's kind of a DIY solution. So you have to set up your own server. You have to configure that server. You have to install Jenkins. You have to then configure Jenkins. And the configuration overhead for Jenkins is really high. It does take quite a lot of work to get Jenkins up and running and doing your builds and doing your code signing correctly and running tests reliably. It does take quite a bit of work. On Travis CI, this is a hosted solution, not just for mobile, but they do offer OS X support. There are lots of plugins. The setup process is not tailored to mobile, so it is a bit more work than some of the other mobile-specific solutions out there. But it's a really well-known, trusted solution, really solid, good support as well. Ship.io, I'm obviously a little biased, but Ship.io, it's a hosted solution designed specifically for mobile, and it's designed to have a really easy setup process. So one of the value props for Ship.io is to basically get you up and running with mobile CI as quick as possible. And so does builds, does tests, integrates automatically with Hockey app and also the Crashlytics beta as well. One of the downsides is that because it is tailored so specifically towards mobile and designed to be so easy to set up, it is less flexible than some other solutions out there. Xcode has its own CI platform built right into it. A lot of people don't know this, but you can set up your own Xcode CI tool, build server just using Xcode. One of the really nice things about it is it's integrated right with Xcode and it's Apple supported. One side with this is that it is self-hosted and it is iOS only. So I forgot to mention that some of the previous platforms I mentioned, like Travis CI and Ship.io, they also support Android as well. Whereas Xcode CI will only host iOS applications. That's the end of my part of the talk. I'm going to go ahead and turn it over to Christian Meyer, who I believe has a demo for us.
Yeah, a lot of good information there. Give me 1 second here to get set up.
A reminder to everyone on the webinar today, we are recording this, and we'll send out a copy of the recording and slides to everyone who is registered for this. Also, we're taking questions in the Q&A panel, so if you look to the right of the screen, there's a little question mark there where you can submit questions during the talk.
Ken, yeah, hey everybody. Once again, I'm Christian Meyer, sales engineer with Sauce Labs, and I'm going to kind of show you how we fit into the whole continuous integration, continuous delivery picture. And I promise you, I only have a few more slides. We'll get into the demo. We don't want to bore you to death by PowerPoint here. But the idea behind CI is, as Kevin mentioned, is automation of deployment and automation of testing. And we work with Travis, Jenkins, all the CI tools, Ship.io, all the CI tools out there, and we fit into where once you do a Git push or commit to GitHub, the continuous integration platform works with Sauce Labs to run it against multiple platforms and do parallelization of your tests. As we mentioned before, some of the frameworks used to do this would be either Selenium or Appium, and I'm going to show you a demo today of running a native app using Appium to run the different tests on our platform. It's just a nice little picture of how Sauce Labs fits into the ecosystem. You can run your Selenium or Appium scripts from your desktop, your server, your CI integration platform, and connect to our cloud out there. And Sauce Labs is we say we have the biggest Selenium grid out there. We can test over 500 different mobile browser, OS, regular browser combinations, as well as all the greatest OS, Android, Windows devices. It's time for the demo. All right, so this is Sauce Labs. Go ahead and sign in. And then kind of a quick tour of the product. You see here, I have my automated builds, my automated tests here. We can do manual testing. I can start a new session because, as Kevin mentioned, it's very important to do manual testing. So I can go to my URL in here, run my test, pick different platforms as needed. To the config screen. Again, this is just talks about how many different operating systems and configurations you can have. You can see we have over 500 different combinations, anywhere from iOS, Android, Linux, etc. I come in here to our platform configuration, and we make it real easy for you out there to set up automated tests, whether Selenium or Appium. Select your different devices here. In this case, I'll just say iPhone, new operating system, what version, and I can see here that we actually generate the source code in all the different languages that you're comfortable. Because as Kevin mentioned, one of the challenges to testing is how do you get your developers or who's going to actually write the code. And since you have the personnel in place, you can just use whatever languages that they're comfortable with. All right. Behind your firewalls, what we have is this SOS Connect. Basically sets up a secure TLS tunnel and sets up just this in that previous diagram, where you sit inside your corporate firewall, hit our Selenium Appium grid, and do your mobile testing or your website testing from inside your network. And the thing that I wanted to touch on here before going actually into a demo of how it works with Travis CI is we do have all the different integrations, great documentation on how to integrate with different tools, Jenkins, Travis, Circle CI, TeamCity, Bamboo, etc. If you click on this, it talks about how to set it up within your organization. And now what I'm going to show is a demo with Travis CI. But unfortunately, right now they are experiencing some capacity issues, so we might see some latency in the test, but I'm going to walk through how it's supposed to go. Because the whole idea is to speed up your tests, make sure you get accurate results, and so you can continue doing development. Okay. So this is my test. You can see I'm running, this is an Appium script, running 4 different devices in parallel. I got just a basic Android emulator, Google Nexus 7, Samsung Galaxy S4, LG Nexus 4 emulator. You can see that I'm going out to the internet and I'm downloading the app that I want to test. So it's set up automatically, and basically all I'm doing is installing the app, finding an element, and clicking on it. So if integration process, I'm just going to make a change to it, save it, come over to my GitHub, do a update. There we go. And I'm going to say, update for demo, and commit it to my GitHub repository. I'm going to go ahead and hit sync, and this process actually should kick off. But again, Travis has been a little slow today, so it may or may not kick off that test. And we'll give it here a few minutes, or 30 seconds here, and see if it actually goes ahead and kicks it off. If it doesn't, what I'm going to do is kind of fake it. All right, so it looks like that's going to kick off, so I'm going to start it, just do it manually here. Go ahead and run the test. Labs, once that gets kicked off, these tests are going to start to run. You'll see right there, they just kicked off, and we're actually running 4 tests in parallel as we're running through it. And we can actually go in, and if I click on any of these here, I'll go into the Android emulator. We see what it's actually doing. There's a screencast that we give with each test. that runs through it. So this is going to fire up the emulator, it's going to download that app, and there's the contact manager, and it's going to go ahead and click save, and that's the end of the test. We give you a log of what was taking place. We give you all the information that you need, the SIEM log, the SOS log. We give you the video and the screenshots. So now if there is an error, you can actually share this test with the developers who are working with it. You can show them the video where it's failing.
We had a couple of questions come in during the process. One I think is for you, Christian. Someone asked, when SOS Labs, when configuring a device, are you able to pick a specific iPhone, iPad, or at least a resolution?
Yeah, absolutely. So you can choose, even in our SOS Connect configurator here, I can go into the simulator, whatever it is. It might be iOS, iPad, iPhone. You can choose the size of it. You can select the operating system. You can even do things as in where do you want it, in portrait mode or in landscape mode.
Question about Appium as well. Used with Python, does it support all gestures, swipes, scrolls, zoom, pinch, etc.?
Yes. Yeah. Appium actually supports all of that through the set capability. You can do all of the gestures that you would on your device. Now this works for, of course, native apps that you're testing on.
One here for you, I think. The question is, how many hours does it take to create all the automated tests? But I think the bigger question there is, if you're moving from manual to automated testing, maybe what's that process and what does that save you in the long term?
Sure. So as far as how many hours, that's a really complex equation. Depends on how big your app is, how many people you have, what the ramp-up time is for them to learn the testing tools. As far as, kind of what does that save you in the long run, I think it has to do with risk mitigation and also offloading work from human beings to your automated tests. So ideally, you end up having a return on investment by doing all the work to create these automated tests, and then you're no longer depending upon human beings to reproduce that same work. And so, ideally, you have a net positive because you're taking work off of human beings. Also, you're ideally mitigating risk because, you don't have to rely on human beings in order to constantly reproduce this functionality and validate that it's working. You can count on your automated tests to do all of that. So in my opinion, it comes down to, mitigating risk and then offloading work off of human beings and onto your tests.
Questions come in. Can I automatically read logs, like catalogs during testing and things? You want to talk about the different kinds of outputs that Appium has for the developers and testers?
So you can access all of that information here within the actual tool. So we give you under the metadata tag, you can read all the different log files, and in fact, you can actually have APIs that you can connect to. If you just Google or SOS Labs API, you can grab all of that information right from the API and put it into your any sort of system that you have.
Another question for you, Christian, I think, is does the automated test configurator only, I assume, work for simulators?
No, not at all. We have simulators, and it's kind of we're finding out in the industry, it's kind of, as Kevin mentioned as well, it's maybe, 80% of your tests are going to be done on simulators and emulators, but we also have the ability to connect to real devices as well. Right now, for the free clients and the trial accounts, the real devices are not available, but for our enterprise customers, they're being used in beta. In fact, we are rolling that out to the general public here shortly.
Another question is, can you use Appium Sauce Labs to test mobile websites as well as mobile apps?
Absolutely. So the idea behind the kind of the difference between Selenium and Appium is Selenium has the ability to test websites as well as mobile websites on different devices. And if you allow me a second here, I'm going to pull up a script that shows you that. This is actually a Selenium script. And in this case, I'm looking at a Windows 8 device, or Windows 8.1, OS X 10.8, as well as an Android and an iPhone, exact same test. So I'm testing on websites as well as mobile web. You want to use Appium specifically is on native apps for Android and iOS, but Selenium can be used for hybrid apps as well as mobile websites. The Selenium commands work within Appium, and Appium adds the ability to do the gestures, the swipes, the scrolls, the finger zooms, things like that.
A question in here about does Sauce Labs support Calabash scripts, Android and iOS?
Yes, we can work with that. We do have companies use Calabash.
Is there documentation on that they can find online?
There is documentation as well. Sorry.
Go ahead. Does the test configurator work only for simulators?
No, actually. So you can see here, it's kind of similar, same one. We can add real devices, and that will, when that is released, because right now it's in beta, when that is released, that'll be updated as well.
Here for you, Kevin. Are there any plans for ShipIO to add Windows app support?
No. I think, the short answer is there are not currently plans. It's not that they won't ever do it. It's just as far as I'm aware, they're still focusing on being the best at iOS and Android. And if Windows is really important to you, reach out to them. Their support is really, really good. And the more people say, hey, please add Windows, the more likely they are to do it. But there aren't any plans right now.
About, I think, the capabilities in Sauce Labs. Will screencasts be available for real device automation through Sauce Labs, the same as it is for emulators?
Yes, all of our tools, all of our logging, all of the screencasts and screenshots will be available for real devices as well.
And what about the iOS simulator life cycles? Are those managed by us, or does the user have to manage that through their own test scripts?
The user manages test scripts, so nothing is stored, or actually your scripts are not run on Sauce Labs. If we bring it back to the idea of continuous integration, those scripts will live and run on your CI server itself.
Terrific. Well, thank you. Kevin, thank you very much for your time.
Thank you.
I want to remind everyone that we have recorded this webinar today, and we'll be sending out copies of the recording, links to the slides. We also have a white paper in development that we'll be able to send out towards the end of this week that will discuss more detail about best practices for mobile CI. Thank you, everyone, for attending, and have a nice afternoon.